then I would use the ones with the R's in them, right?
Okay.
The R means common ratio.
You didn't go over that one, right?
Of course I did. Yes. I never leave a section without finishing it. And we got into 5A. Yeah.
5.782.
What's that?
5.782.
82. Oh yeah, that's my favorite. So samurai folding the sword, right? I always think about Kill Bill when she goes, "You make me a sword." I don't know. Okay, well. What everybody makes a mistake. They always have the answer half what it's supposed to be. Number 82. Yeah. Think about it. If I fold that once, how many layers are there? 2. But everybody sets theirs up so that the first layer is 1. No, it says, let me show you what I'm talking about. So n here represents the number of times I'm folding it, doesn't it? All right. So what you should do for this problem and other problems like, not word problem, but wordy problems, right, is actually set up some elements of the sequence. So number 82. If I fold it once, how many layers are there? 2. 2. So you start at 2. Fold those again. 4. Fold those again. 8. Careful. Right. If I fold 4 on top of itself, that's now 8 layers, right? And so forth. What type of sequence is that? Geometric, because I'm not adding the same thing every time. I'm always multiplying by 2, of course, and that's only like, of course you're multiplying by 2 because you keep folding it over, so you're doubling the layers, right? So what's A1?
A1 is
2. What's R?
2.
2, because you keep multiplying by 2, right? And that's a mistake people make. People set it up so that A1 is 1. But A1 is 2, because what do I want that 1 to represent? The first fold. So then when I do 15 folds, it'll be right. So a lot of people turn it in, they have half the right answer because they started at 1, not 2. You guys get the idea there? So I mean, now it's just plug and chug. They want to know what what would AN here be? It's A1 times R to the n minus 1. So AN would be 2 times 2. Some of you guys might realize you can simplify that, but they're like bases, but you don't have to. And then I want to know A15, right? Okay. So now you can do that. Cool.
4 times. I'm getting confused with your exponent and your
It's
exponent.
still going to be 14.
Why?
It's the formula.
Yes. It's the formula we spent all that time trying to set up. Because if I want to get to the nth term, how many steps do I have to take to get there? 1 less.
1 less.
So n's 15.
The formula itself has an n minus 1.
So
that's the formula, the way the formula is.
So how would you? So it's 2 times 2 is 4.
And what does that have to do with this problem? Because you can't multiply before you raise. So don't go against PEMDAS ever.
So is it 15 minus 1 is 14? So
I love it.
2 to the 14th power.
2 times 2 to the 15 minus 1. Just plugging in 15 in. So 2 times 2 to the 14th. And plug that in your old calculator and see what you get. Big ass number. What's the big ass number? Hopefully it's 32,000.
Yeah.
Sweet.
32,700.
And the number I keep getting in the homework is 16,000 something. Half of what it's supposed to be because people are starting at 1, not 2. But write a few elements out related to the problem. That'll make sure you start at the right place. Yeah.
For our homework, are you gonna be like upset if we skip writing down that step? Because if I already know that it's 15.
No, I mean, I write out more steps just so everybody,
Yeah, I just
if you
want
don't have to write
sure.
out all these steps. But personally, definitely do this for yourself. Summarize what you know and then throw in the formula. You have to do every single step I do.
Okay, I just wanted to make sure. Thank
Okay.
you.
Shelby. So, anybody else didn't get their quiz back yet? Okay.
But that would be the formula you would use for that. Remember that question was, would you like a penny that would double every day for a month
Yes.
or 1,000? That would be.
Well, it's not
Similar to that?
exactly the same. Yeah.
Oh.
How do you do not
I just
know
remember
what
that
the
one.
exponents in
Something I
there
saw one time.
Like if I do 2, how do I do 2 to 14?
All right, guys.
I can't
So
do that.
yeah.
The second. I think for the second.
But then you said like it's second what?
Wait.
Whatever you want, whatever like.
Hey guys.
Exponent.
Guys.
On 5.8 on number 20, do you want us to actually measure the desktop in the classroom or any desktop?
Any desktop you can get a hold of. And just tell me where you are when you do it. Yeah, you did?
Because I wanted to do that.
Let's do that one. I'm curious now, does anybody have classes over in the new health sciences building?
Yeah.
What do you think about the chairs?
I love those chairs.
I hate them. I am so happy I don't have to sit in them. And the top of them is all pebbly.
And it's too small.
Yeah.
I know.
Yeah, that's the college. You can't blame us too much because we don't have much money. But at the same time, my God.
Okay, did you figure it out?
All right, guys, if you're
Which
paying
one is it?
attention,
Which
I'm going to do a
platform?
homework problem for you.
Yeah.
Hey, look at that. So these desks are 20, or let's say that's 20, we'll go and say that's 24 by 18. So what's 24 divided by 18? That's actually pretty cool. Comes out to be that evil number.
1.3333.
Oh, it's not the evil number. No, it's 1.33, yeah. And that's not really close to 1.618, not necessarily. It's not far, far away, but it's not as close as I'd want it to be. The one that talks about measuring a desktop. Put a note to yourself. The one that talks about measuring a desktop. So, do desktops have to be necessarily aesthetically pleasing?
No.
Okay, so it's up to you guys. They don't. They just have to be freaking big enough, and that's another thing. I don't think those in the health sciences are really big enough.
You
Yeah.
can fit a notebook on it, that's about it.
Yeah. I like classes where you have like tables, and you sit next to somebody and you can
Like
always.
a science lab.
Yeah. But oh well, too bad for us.
Thank
These
you
are
for the
decent,
number.
actually.
Yeah, these aren't bad.
Okay. All right, guys. So we're gonna get into new stuff today. And actually, what I just did there was really the extent of the homework in section 5.8. It has you measuring a few things like your TV screen. If you don't own a TV screen, just say, I don't own a TV screen. That's fine. Don't lie if you do. Just do it. See,
Go to Walmart.
in fact, who knows what a widescreen normally is? What the ratio is? 16 to 9, really.
Well, I just know we measure corner to
And what's 16 divided by 9?
Huh?
Look at me, my hand out of batteries. Huh? 1.7, that's pretty decently close to 1.618, right? Interesting. All right. So we're going to get into some funky stuff today, as if we haven't already. Yeah. And to reiterate what Ryan noticed again is we start with section 4.3 and work our way backwards through 4. The next test is only going to go up to 4.3. Because the next class is review day, I can't do any new stuff then. So we'll do 4.2 and 4.1 after this next test. But here's the idea behind 4.3. And really, this is one reason why I love this class, is because you guys get a lot of mathematics that you need to go through to see how it works. But the thing you guys don't really get exposed to a lot is it didn't have to be the way it is. Our mathematics could have been so different, right? Even something stupid like where we put an exponent. Why is it up there? It could have been anywhere. The guy who came up with it could have put it right there. But that looks like a fraction, right? And he could have put it right there, but that looks like maybe it's x times 2. So, I mean, that's a really decent place to put it. And why didn't he put it in front? Because some other dude beat him to it. Somebody else said, no, that means x plus x. And I'm like, damn you. Let me put mine up here. Right? And then we just made sure everybody understood what that means. You guys kind of see what I'm saying? So that's kind of lame, really, but yeah.
It also makes sense because it's like the meeting point of a 90-degree angle, which is the square, because it's right here.
Oh, I see. So like in that corner is the 90-degree angle, which is a square. And then they just said, we'll put other numbers there too. Okay. Because it could be a cube up there, right? Yeah.
But it will always be for a two-dimensional grid. So
I like it. I like that. I never thought about it that way. I don't know if that's the real reason, but why not? What about something else like, what does this symbol there mean?
Root. How many?
We know what it means because we were told what it means. We know what it represents. What's the answer and why is that the answer?
3.
Why?
2 numbers.
So the square root, we know what it means. It says find a number it takes 2 of to multiply to be this. That's what that symbol represents. Did it have to be that symbol? No. Somebody sometime in history decided it would be that symbol and enough other people agreed. And they killed anybody who didn't. It was a bloody history of math. The little known history. All right, so what we're talking about today is actually even more fundamental than that. Even more fundamental than what the first 2 sections of 4 cover. The first 2 sections of 4 cover what other civilizations did. So obviously, hopefully you all know that these symbols here are symbols that we use. And actually, most of the world nowadays uses these symbols. But not everybody uses these symbols. And throughout history, there have been a lot of different symbols people chose for these numerals. So these are numerals which represent the idea of number. So I've got 2 hands. We use this symbol to represent that quantity. But, you know, for example, the Mayans used this symbol to represent 2. Right? The Chinese, ancient Chinese, anyway, used this symbol to represent 2. Right? So forth. So we're going to learn some Chinese, some Egyptian hieroglyphics, some Babylonian numbers, sweet stuff. So what we're going to focus on now, before we get into different numerals, the reason why I do 4 backwards is because 4-3 still has our numerals, so it's nothing too major of a change. What we're changing, though, is our base. So what do I mean by that, our base?
Base of 10.
Beautiful. And I think I've pretty much alluded to this earlier in this class. Why is our base 10?
10 fingers.
And that's the best theory going, and I think that's why. It only kind of makes sense, because there's actually a tribe who uses, I don't know if they're still around now, but they use, like, they count from their feet up the side of the body, down their fingers, and then around the corner, and so the words for those numbers are the body part words as they get to them, right? So, of course, you can imagine early on, before we even developed language, we could still say, 2, not 2, but, 1, 2, 3. These are the first things we would use to kind of keep track of stuff. Since there are 10 of them, we'd start over again at 11, right? So we get up to 10, that's a special thing. 11 starts over. So what if there were 8? We can't lose our thumbs. That's why we evolved, right? Opposable thumbs. That would suck if we lost them. So let's say we lost our pinkies. I think maybe we can survive without our pinkies. I can still grab things, right? So what if we had 8 fingers? What could our number system look like? Right? So the way I approach this is to start with a problem that's not so earth-shattering. It's actually pretty simple. If I have a carton of eggs, there you go, Jeff, and 8 eggs fit in this carton, right? So we got 1, 2, 3, 4, 5, 6, 7, 8 eggs fit in this carton. 8 eggs per carton. And there's a crate that can fit 8 cartons per crate. You guys get the idea? Mm-hmm. So I can have some loose eggs laying around. I can have some filled up cartons, and I can have some filled up crates. Cool? Okay, good. So, think about this. If I had 9, what are you doing, Jeff? If I had 9 eggs, how would that break down between this? What would I have? I'd have
1 and 1 in.
I'd have, how many full cartons would I have? 1. And then how many loose eggs would I have?
1.
So I'd have 1 carton and 1 loose egg. Cool? This is actually the number 9 in base 8. Because in base 10, what does this mean? You guys are like, it means 11, Joe. Please don't tell me it means 10. That's neat. It means 11. What does it really